Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video, we're going to do an applied problem related to linear programming. Now, this is not the most important problem in the world, but cookies and cupcakes are important too. A baker has a home-based business making cookies and cupcakes, which he sells by the dozen. So I'm going to let X represent the number of cookies that he sells, and this is in dozens, and we'll use Y for cupcakes. Those are our two variables here. When making cookies, he must make at least 6 dozen, but cannot make more than 18 dozen. So that tells us that the cookies has to be somewhere between 6 and 18. The second sentence, when making cupcakes, he cannot make more than 12 dozen. That tells us that Y has to be between 0 and 12. And probably not even equal to 0, but nonetheless, the number of cupcakes he makes cannot be more than half the number of cookies he makes. The number of cupcakes, Y, cannot be more than, less than or equal to half the number of cookies, 1/2 X. So we've got, in the blue, we've got a couple of vertical lines. In the red, we've got a couple of horizontal lines. And then the purple inequality is going to hopefully go through the box that makes. And we're trying to maximize the profit here. And it says the baker makes a profit of $4 per dozen cookies and $8 per dozen cupcakes. So it would make sense that you would want to make as many cupcakes as you could. However, the number of cupcakes he can make is restricted by the number of cookies he can make. So it's not going to be just make all the cupcakes. It's going to be how many cupcakes can we make based on the maximum number of cookies we can make. Anyway, the function we're trying to maximize here, Z, not sure what's happening here. The pen didn't seem to want to work. Now it does. So we're trying to make Z equals 4X plus 8Y, $4 for each dozen cookies plus $8 for each dozen cupcakes. We want to make that as big as possible. So a little freehand graph here. I'm really just worried about the quadrant at the top right, which we call quadrant 1, because the number of cookies and the number of cupcakes that are made, right, they can't drop below 0. So we'll focus up there. We've got a vertical line at x equals 6 and another one at x equals 18. We have two horizontal lines at 0 and at 12. And now we want to graph in purple, y is less than or equal to 1 over x. So we're already inside of this box, and we want to see where that line crosses through that box. And, you know, it may cross here and here, or it may cross here and here. And we've got to figure out where that happens. Let's get rid of all that. So the graph of y equals 1/2 x, that has a slope of 1/2 and a y-intercept at 0. So I know it's going to start here, and then it's going to go up 1 over 2. When x is 6, 1/2 x is equal to 3. So this point is going to be the point 6, 3. And actually, let me write that on the other side, because I've looked ahead a little bit. And when x is 18, and by the way, 3 is lower than 12, so I know that putting that point there is okay. Half of 18 is 9, and that's below 12. So that means that it's going to cross somewhere around here at 18, 9. And it's not going to cross the red line at 12 until somewhere outside of the region. Now, we were looking for y to be less than or equal to 1/2 x. So the region we're working with is here inside of the green. We were inside that rectangular area, then the line that went through it, we wanted to be below that. So that's how we got this piece right here. I already know the coordinates, by the way I graphed it, of 2 of the 4 corners. I also have this one here is 18, 0, and this one here is 6, 0. And so the maximum has to occur at one of those 4 ordered pairs. I think we have a good idea of which one it's going to be, but this is the way that you would go through it no matter what kind of problem it is. So for the, I'm going to take the points from left to right. So I'm going to start with 6, 0. Z equals 4 times 6 plus 8 times 0. That's 24 plus 0, or a $24 profit if he bakes 6 dozen cookies, and that's it. For 6, 3, that's 6 dozen cookies, 3 dozen cupcakes. That's going to be 4 times 6 plus 8 times 3. That's 24 plus 24, or $48. So he'll make $48 if he bakes 6 dozen cookies and 3 dozen cupcakes. The third corner, 18, 0, Z equals 4 times 18 plus 8 times 0. That's 72 plus 0, or $72. So far, he would make the best profit by baking just 18 dozen cookies and no cupcakes. But we've got one more to go, and we know that by adding on those extra cupcakes, we're going to be adding on some profit there. For 18, 9, Z is 4 times 18, which we know is 72 already, plus 8 times 9, which is another 72. That is $144. So the maximum profit is $144 from 18 dozen cookies and 9 dozen cupcakes. So the strategy here is, from the wording in the problem, try to come up with the boundaries of the region. Sometimes they're going to be simple vertical lines or horizontal lines. Other times they're going to have some kind of a function, and it doesn't have to be, doesn't necessarily have to be linear here either. But then we figure out all the corners, all the vertices, and we evaluate the function at each of those. The maximum has to be at one of those locations. All right, that's it for this one. That's the end of this section and for us, this chapter. So I will see you in chapter 10.